Hello, in this video, I will explain to you on how to find out this node voltage VA in this circuit using branch current analysis. So our goal is to find out what is VA, the voltage at the node A. Okay, and we need to use the branch current analysis. Branch current analysis. And let's do exactly that. The first thing that we need to do is to assume the current direction, the current directions for each component, right? For each components. We have 2 batteries and 3 resistors, so we have 5 components. And let's see what can we get from here. So I assume the batteries here, the 4-volt battery, giving current to the circuit. So I will assume it goes up like this. And for E2 here, I also assume this battery is also giving the current to the circuit. Okay, so let's name this current here as I1. And also let's name this current here as I2. And because this is in series with R1, we will have this current that pass through R1 here is also I1, right? And here the same case, so we will have the current that pass through R2 is going to the left like this, and the value will be I2. Good. But here, I will assume that it will goes down like this for the current that pass through this R3 resistor. So we'll have I3. Okay? And then we need to do KCL for each unknown junctions. Do KCL for all junctions or the nodes, right? And here we only have one unknown node, which is node A. We know this node here as our ground, so we know the voltage here will be equal to 0. So we only need to do KCL at node A. Okay, let's do that. KCL at node A. And what does KCL say? KCL said that the sum of the current that goes in will equal to the sum of the current that goes out, right? And what is the current that goes into node A? I1 and I2, right? So we will have I1 goes in and I2 also goes in. So I1 plus I2. Okay, and all of that will equal to I3. And we will have our first equation here. Good. Now, let's do the third step, which is to draw the loops. Draw the loops. And assign the polarity. Assign the polarity for each components. For the batteries, we have already the polarities here, minus and plus, plus and minus, but we need to do it for the resistor, right? So here I will have I1 goes up and then I1 goes there and then it will goes down. So this is our loop here. I will assume that it is going clockwise in this loop. So let's name this as loop 1. And then here, because we assume that this current I2 is given by the 6-volt battery, I will make this loop here is counterclockwise like this. So this is loop number 2. And now what we need to do is to assign the polarity for each resistor. Okay? In each resistor, the current comes from the positive side and it goes to the negative side, right? Because it goes to the right here, so it comes from here and it goes here, right? Because the arrows goes there. And we can also apply the same logic here because it is going to the left. The positive side will be here and the negative side will be here. Good. And then for R3, it goes down here, so the positive side will be on top, and then the negative side will be on the bottom. Okay, and all good until here. Let's do KVL for each loops, which is loop 1 and loop 2. Okay, let's do the Kirchhoff voltage law, KVL, at loop 1 first. At loop 1, and what does KVL say? KVL said that the sum of the voltage in a loop will equal to 0. Good. Now let's start from this battery here, and let's see this loop here. The loop enter from the negative terminal, so we will have minus sign. So we'll have minus, and we already have the voltage, which is 4 volts. So I will have minus 4. Good. And then plus. Okay, let's move on to this 4 ohm resistor. So we'll have 4 ohm, but then this is resistor. To get the voltage, we need to multiply it by the current. And the current that passed through this resistor is I1. So I will have minus 4 plus 4I1. Okay, and I think that is good. Now let's move on to the resistor number 3. Again, it enters from the positive terminal. So I will have positive sign. And we will have 8 ohm here. But 8 is resistor. To get the voltage, we need to multiply it by the current. And the current that passed through R3 is I3. So I will have I3 here. And all of that will equal to 0. But then we can move things around here. So we'll have 4I1. And then plus, I think I will have 8I3. But then I3 is this current here. So we will have I1 plus I2. And that will equal to 4. Okay. Now doing some math here, I1 will be 4 plus 8. So I will have 12I1. And then I will have plus 8I2. And that will equal to 4. And I think that's good. From now, let's do another KVL, but this time at loop number 2. KVL at loop 2. Again, KVL said that the sum of the voltage here is equal to 0. Good. Let's start from this 6 volt voltage source or battery. And the current enter from the negative side. So I will have minus sign there. And we already have the voltage, which is 6. Okay, so we'll have minus 6 here. Then plus. Here the resistor is 2 ohm. So I'll have 2. But then to get the voltage from resistor, we need to multiply it by the current. The current that passed through this resistor is I2. So I will have I2 here. And the sign will be positive because it is entering from the positive side. Good. And now let's move on to this component here. And we need 8 ohm resistor. So we have plus 8. And remember that this is a resistance. We need voltage. So we multiply it by the current that passed through it, which is I3. Okay, and all of that will equal to 0. So we will have 2i2 plus 8i3. But then I3 is I1 plus I2. So I will have I1 plus I2. Okay, and then all of that will equal to 0. No, not 0. Let's move this minus 6 to the right hand side. So I'll have 6 here. Good. Now simplifying this, we will have 8i1 and then plus 10i2. Okay, and that will equal to 6. Okay, we have done the fourth step, right? Which is actually do KVL for all the loops. And then let's do the fifth step, which is to solve the equation, right? Solve the equations. Okay, now we have two equations with two variables, right? We have equation number 1 and equation number 2. And I think we can solve this equation faster using calculator, right? So we will need to solve the equation. Solve 1 and 2. And let's take out our calculator and calculate that. We'll show you how. Let's set this up as equation solver, which is number 5. And two variables, because we have two equations with two variables, is number 1. And then I will have 12. And then 8. And then 4. That is the first equation, right? 12, 8, and 4. And then I will have 8. And then 10. And then 6. Good. And now I will have the value of I1, which is minus 1 over 7. Okay, let's get that. I1 is equal to minus 1 over 7 ampere. Or maybe let's write that in decimal here. So we will have minus 0.143. Minus 0.143. I think I will need more digits here. 286. Okay. 286 ampere. Or I can rewrite this as minus 142.86 milliampere. Right? But then we can calculate I2. Here, which is the Y value from the calculator, which is 5 over 7. Okay, so I have 5 over 7 ampere, and that value will be 0.740. Okay, 0.714, and then 28, I think. Yeah, no, 29 ampere. Or I can rewrite this as 714.29 milliampere. Okay, but then what is I3? Okay, we can calculate I3, right? I3 is just I1 plus I2. And we know that I1 is minus 1 over 7, I2 is 5 over 7. So that will be 4 over 7 ampere. Or we can write that in decimal. What is 4 divided by 7? 4 divided by 7 is 0.571. Okay, 0.571, and then 29. Yeah, 29 ampere. Or we can rewrite this as 571.29 milliampere. So that is I1, I2, and I3. But then our goal is to find out the node voltage VA. So what is VA? And that is the last step, which is answer the question. What is VA? VA is I3 multiplied by R3, right? Because VA here is the difference between this node and the ground. But that is equal to the voltage across this 8 ohm resistor. So I will have I3 multiplied by R3. So we will have VA is equal to I3 multiplied by R3. But what is I3? I3 is 4 over 7. Okay. But then R3 is 8. So I'll have multiply this by 8. So I'll have 32 over 7. But then 32 over 7, what is it? Let's use calculator for that. 32 divided by 7. That will be 4.571. 4.571 here. And the unit will be in volt, right? And that is the final answer for this question. And we have achieved our goal here. Okay, I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.